components of ladder logic. So in this class we are going to discuss about the logic Boolean. So in this class we are going to discuss about the logical arithmetic operations, that is AND or NAND or XOR gates. So we start from gate. So Taufik will come and explain the truth table of the application.
I will explain about the truth table of AND gate.
So in truth table, we have two inputs and one output.
If either of is 0, it's in off state. When both of the input is in on state, it should be output will be in on state.
Okay. Thank you. Now I request Deepak to explain the ladder logic program function. Here 0 is low, 1 is high. Or if 0 is off state, 1 is on state. It is a digital form of outputs. This is a ladder logic circuit for AND operations. We have two inputs, so one output. So name the two outputs. This is x0, x1, and then y0. Okay. Just explain.
As you can see, we have two input devices, X0 and X1, and one output device Y0. From truth table, we can clearly see that when two inputs X0 and Y0 are in the off state, our output will be in the off state. And
the both switches are turned off now. There is no current flow from left side to outside. Positive output will be the 0. Okay, and then next condition. So this is the ladder logic circuit diagram for the AND gate. Deepak will explain the AND gate along with the truth table.
as you can see here, we have two input devices X0 and X1 and one output device Y0. From our truth table, we can easily determine the output state of this ladder logic. If both inputs A and B are in off state, which is X0 and Y0, our output will be in off state.
Even two inputs are turned off, so there is no current flow from positive to negative. Then output will be the 0, off state. That is the output. Okay. Moving to the second condition.
In our second and third condition, even if either one of the input devices is
turned off,
our output will still be in the off state because we need both the input devices.
For example, if the x0 is turned on now, the current transfer current flow from positive to reach the x1 up to x1, but after the x1 it will not turn. Okay, because x1 is 0, so it does not allow the current flow in this state. Okay, then output will be 0. Likewise, 0 1 1 0. Okay.
Finally, our last truth table, where both A and B are in on state, we will finally get our output as 1. Similarly, here both X0 and X1 are in on state. Our Y0 will finally be power supply, and our output is 1.
Okay, very good. Okay, in previous session we discussed about the AND gate truth table as well as ladder logic diagram. So today, now we are going to discuss about the topic of OR logical operation. So I request Amit to explain the truth table as well as logic. So in this OR gate logic also we have two inputs and then one output.
So not gate, during not gate regulation, not gate either if any one of the outputs, any one of the inputs are turned on.
Okay.
The output will be turned on. So it doesn't need to be both of the inputs doesn't need to be. Either one of them will be you check on the